All right, looking at section 7 here, and we are factoring special products. Now, the one big thing that we want to get from here is this top one here. This is the difference of two squares. Now, earlier, we talked about conjugates and difference of two squares, and that's where this really comes into play. We remember that whenever we have conjugates like we do right here, the middle pieces, they end up canceling out when we multiply. And that leaves us with just the beginning squared and the ending squared with a minus in the middle of it. So we're going to be utilizing that trick there. Now, this second piece here, these formulas are great. If you want to use them, you can. I normally don't end up using them though. Let's look at example 36. This is a binomial, right? It just has two pieces. I see that the first piece is x squared, and I'm going to rewrite the second piece as 10 squared. So I'll say x squared minus 10 squared. Now this is a difference of two squares, okay? Eventually, you can skip this step and you can just jump to the answer, but for now I think it's good if we write it out, right? Difference, meaning minus, of two squares. Well, there's two squared pieces there. This is going to factor to be x plus 10 and then x minus 10. And that's our answer there, right? These two items are conjugates, which means that their middle pieces cancel out. And that's why this one works out the way that it does. If you want to, you can multiply these out to the side, but I'm going to leave that as is. 37 here. This one, again, is a difference of two squares, but it's a little bit harder to see. The first piece is 6y squared, right? 6 squared is 36. Y squared is y squared. And then minus 5 squared. So factoring it in the same way that we did above, we're going to have 6y plus 5 and 6y minus 5. And there we are. 38. This one we go back to section, I think it was section 5, where we were just finding two items that multiply to be 64 and add up to be 16. It's going to be 8 and 8. So here, we could write this as x plus 8, x plus 8. But instead of leaving it like that, I would like to list it as an item squared. So I'm going to say this is x plus 8 squared. And that's the way I'd like us to list our answer, okay? So if you have two binomials that are multiplied together, or two anything that are multiplied together, and they're the exact same items, I'd like to list them as squared or cubed now. So that's what we're doing there. That's the big difference from the previous stuff. Let's look on. Number 39. Now this one here is a little bit more difficult. Could we factor something out? I think we could pull a 3 out of everything. I think we can. Let's do that. So we'll pull out a 3, and that leaves us with what? 3w squared minus, what's 42 divided by 3? That gives me 14w plus, 49 doesn't divide out of 3. I don't know what I was thinking there. All right, well, I guess we have to do it as saying 9 times 49. That's going to give us a big number. That gives us 441. Now, what can we break that apart to be? I bet it's 21 times 21. It is 21 and 21. And that so happens, if we made them both negative, that would add up to be negative 42. So this here we can break apart to be 9w squared minus 21w minus another 21w plus 49. Right, remember, just like in the last section, those two add up to be the middle guy. Now we want to break apart this first piece. We can pull out a 3, and we'll be left with 3w's. Oh, we can pull out more than just a 3. We can pull out a 3w. 3w, and then we're left with w minus 7. And then we pull out a, what can we pull out? Oh, this is a 3 here. There's a 3 there, good grief. We can pull out a, what can I pull out? pull out a 7, right? Yeah, 7. And I'm going to make it a negative 7 because that gives me positive 3w minus 7. There we go. There we go. Now these guys are the exact same thing, so they can come out front, 3w minus 7. And then our leftovers are 3w minus 7. Seeing that, they're duplicates, right? So we're going to write them as an item squared. So we're going to say 3w minus 7 squared. There we be. That one was a little bit longer. Well, not necessarily longer, but more difficult. 40. Going back to a binomial. This one here is the difference of two squares. It's going to be 3x squared minus 6 squared. This is going to be, what, 3x plus 6, and then 3x minus 6. Now, we could actually factor more. So this direction is our factor. We could factor more. Because if you look at both of these guys, we could pull out a 3. So I'm going to say, well, this is 3, and then x plus 2. And then our second one is a 3, x minus 2. The 3's can multiply together and be out front, and it's going to be 9, x plus 2, x minus 2. There's that. And actually, looking back up top, had I noticed this, I could have pulled a 9, and then we'd have x squared minus 4. And that would be 9, x plus 2, x minus 2. So we could have done that as well. Both processes are good, but I'm glad that we were able to see that we can factor in the later part of it, right? If you don't notice to factor something out in the beginning, it's not like it's lost. The problem isn't lost. You just have to make sure you check it at the end to make sure that it's factored, right? So right here, I thought that we were done, and then I noticed that we could pull out the 3's for both of those, and then I noticed about the first ones, and then we were able to continue on and get the correct answer. All right. Example 41. All right, looking for things that multiply. Now, because we're doing some fancy, what was it, the last ones where there were duplicates here, the 21s, I'm wondering if I need to look at duplicates going into 34. So what would that be? 15, 16, 17 maybe? Is 17 times 17? Oh, it is 17 and 17. So this is going to be x plus 17, x plus 17, right? 17 plus 17 is 34. And then we want to list this guy as squared, so it'll be x plus 17 squared. And there we are. All right, scrolling down to our very last problem. Well, I look and see, can I factor anything out? And I'm not seeing anything that could factor out, right? The first one is a 5. Yeah, nothing's going to work out. So now I need to take the 25 times 36. That's going to be a big number, 900. And then I want to look and see, can factors of 900 add up to be 60? And I'm going to try, what is 900 divided by 30? Well, that's 30. So we'll try 30 and 30. Those add up to be 60. So that's going to work out. So we'll say 25c squared plus 30c plus 30c plus 36. I look at the first pieces and the second pieces together. I can pull out a 5c out of the beginning, and I'll be left with, what, 5c plus 6. And then I can pull out a 6, and I'm left with 5c plus 6. Factoring out, I'm going to have 5c plus 6, and then another 5c plus 6. Because they're the exact same thing, I want to write it as one item squared. So 5c plus 6 squared. And there we are. All right. That was factoring some special, what was it called? Special products. Okay. Now these formulas here, again, they're great formulas. If you can recognize them, if you can use them, that's awesome. Sometimes they're kind of hard to use. Sometimes they're kind of hard to recognize. So whenever I went through these, I went ahead and did them by hand as if I didn't notice the formulas. But anytime we see that the first piece, right, so like this one especially, 25c squared and 36, those can both be written as like items squared, which signify that we could have used those formulas there. But we were able to do them by hand. We were able to get to good answers. So, all right, that is that.